Good morning. Today I am going to do a brief lesson on stoichiometry. We are doing mass-to-mass stoichiometry problems. And I'm going to teach this in class as well, but I thought I would make this as a resource in case you needed an additional explanation. So stoichiometry is a process that we use in chemistry. And we have a few steps. You wrote these down in your notes, either Tuesday or Monday, I believe. And there are 5 basic steps that you have to go through to have a successful stoichiometric calculation. And the first is to make sure that you have a balanced chemical equation. Generally, if you are provided an equation that already has coefficients, you can assume it's balanced. But if there are no coefficients, you'll probably want to mentally check that it's balanced. The second thing that I recommend you do is, as you read the problem, you refer back to the chemical equation and circle the substances that you're considering. For example, in this problem, it says how many grams of potassium oxide are generated from the decomposition of 240 grams of potassium permanganate. So looking at my chemical equation, it is balanced. I'm going to start by circling the substances that this problem is asking me to consider. So the first one I get to is K2O. And the second one I get to is KMNO4. Notice that I'm also including the coefficients when I circle because they will be a part of the process. Our third step, after we have an equation that's balanced and we've circled the substances that are being dealt with, we're going to start with the quantity in grams that's provided in the problem. So when I read this problem, my gram quantity is 240 grams. So I want to write that down with all of the significant figures I'm provided. And I want to be sure to attach it to the substance that it's attached to. In other words, I've circled 2 substances, but which one of these is attached to that 240 grams? Well, that would be the KMNO4. Now, going back to our steps, I have my equation balanced, I've circled my substances, I've written down my initial quantities that was provided in the problem. And my first step after that is to convert that quantity from grams to moles. So since I'm starting with grams, that's going to go on bottom. Moles of this substance will go on top. Remember, in a conversion, the number that always goes with moles is 1. The number that goes with grams is going to be the number we get from the periodic table adding up the molar masses. So for example, potassium is 39.10 grams. Manganese is 54.94 grams. And 4 oxygens, 4 times 16 is 64 grams. So then I will add those up to get my molar mass. So 39.1 plus 54.94 plus 64. So that my molar mass is 158.04 grams. Always be sure to keep 2 places after your decimal. So this is always your first step, is to get to moles. So we call this the gram to moles step. So after we have done that, we're not going to stop. We're going to continue on. So our next step is to set up the mole ratio with the starting substance on bottom and the desired substance on top. So my starting substance is the one that was attached to the gram, so KMNO4. And what's going to go on top is the other one that I circled, which in this case is potassium oxide. And we call this the mole to mole ratio because if we were reading this chemical reaction we could say 4 moles of potassium permanganate decomposed to make 2 moles of potassium oxide, 4 moles of manganese 2 oxide, and 5 moles of oxygen. So really, chemical reactions are kind of like a recipe in that those coefficients tell you the ratio at which they react and form. So this is where we're actually going to use those coefficients. So the coefficient that's going to go with KMnO4 is 4. The one that will go with potassium oxide is 2. We call this step the mole to mole ratio step because I'm going from moles of one to moles of the other. And then looking back at our steps, the very last step is to convert this new substance from moles back to grams. We can't weigh out moles, we can weigh out grams. So we always start and end at grams. So our last step is to go from moles back to grams. So for our new substance, we'll have moles of that new substance on bottom and grams on top. Once again, in the mole to gram conversion step, the number that always goes with moles is 1. And where do I get the number for grams? Well, I'm going to have to add that up using the periodic table. So let me come down here. I've got 2 potassiums, so 2 times 39.10. And I've got 1 oxygen, which is 16. 39.10. That would going to be, let me just multiply that really quickly, is 78.2. When I add those, I'm going to get 94.20. And so that'll be my molar mass up here. Now, remember that when we're doing the math on these, the first thing we want to do is make sure that our units cancel. And then we will put it into the calculator by multiplying all of our numerators and dividing by all of our denominators. What do I mean by making sure the units cancel? Well, you notice how I started out with grams, and I've got grams on bottom. I've got moles of potassium permanganate on top, moles of potassium permanganate on bottom, moles of K2O, potassium oxide on top, moles of potassium oxide on bottom, and I'm ending at grams. So following those units help me to figure out if I've set it up correctly. So the last thing we're going to do is put this in the calculator. 240.0 times 1 times 2 times 94.20. And then I'm simply going to divide by everything on bottom. So literally divided by 158.04, divided by 4, divided by 1. And my answer is, well, first of all, how many sig figs can I keep? These are trailing with a decimal, so they both count. I have 4 sig figs. So if I keep 4 sig figs, I get 71.53 grams of potassium oxide. So that is how stoichiometry works. Let's do one more, just to show you that you don't always go this direction. Here I started with a reactant and I solved for a product. But I can also solve for things going the other direction and on the same side. So here's another problem. Let's review our steps doing this. This problem says, if 83.4 grams of potassium oxide are generated in this reaction, how much manganese 2 oxide should have also been generated? So first step, do I have a balanced chemical equation? Yes. Second step, read the question and circle the substances that are involved. So in this case, I've got potassium oxide, and I've also got manganese oxide, manganese 2 oxide. So they're on the same side. That's okay. The process is still exactly the same. My third step is to start with my gram quantity in the problem. So I'm going to start with my 83.4 grams, and I'm going to make sure to attach it to the substance it's attached to. If you don't do that, sometimes it's easy to accidentally solve the wrong way. After I have my starting quantity, my first step is to convert those grams to moles. So if I start with grams, grams will go on bottom. The 1 mole of that substance goes on top. And remember, we already added this up on the prior side. K2O is 94.20 grams. My next step is called the mole to mole ratio step. And this is kind of like my recipe step. The moles, the substance I'm starting with goes on bottom. The one I'm solving for, the other one I circled, will go on top. And now I'm just going to use their coefficients. What coefficient was with manganese oxide? A 4. What coefficient was with potassium oxide? A 2. And then my last step is to go from moles of this new substance back to its mass in grams. So I'm going to have manganese 2 oxide on bottom and the grams of that on top. Remember that the only place we use these coefficients is in this middle step. Everywhere else, there's just 1 mole because we're doing a mole to gram conversion. And I'm going to need to figure out the molar mass of manganese oxide, because I have not added that one up yet. Manganese is 54.94. Oxygen is 16. So this will add up to 70.94 grams. So let's look at my units to make sure I've set this up correctly. I've got grams of potassium oxide. These are the grams of potassium oxide in 1 mole. I've got moles on top of potassium oxide, moles on bottom, so that cancels. I've got moles of manganese oxide on top, moles of manganese oxide on bottom. Remember, anything in both the numerator and the denominator cancels as far as units. And then I'm ending up at grams. That's what I want to do. In order to correctly put this in the calculator, I'm going to take my initial number, 83.4, multiplying it by all the numerators. So times 1 times 4 times 70.94. And then I'm dividing it by all of my denominators. So literally divided by 94.20, divided by 2, divided by 1. So that my answer is 100, how many sig figs do I have? 3. So 125.6 will round to 126 grams of manganese oxide. It is kind of smart to do a little bit of mental math to make sure that it makes sense. I do expect my number to get a little bigger because this is the equivalent, right, of multiplying it by 2. My mass here, this will make it get, these two will be a number less than 1, but it still should be larger than 83.4, which it is. So that's really how you do stoichiometry. It doesn't matter if they're on the same side, if you're going from the reactants to the products. And in class, I'm actually going to show you one, I believe, where we go from products back to reactants. No matter what you circle, the process is always the same. You start with your gram quantity and whatever it's attached to. You convert that substance from grams to moles, do the mole ratio from what you're starting with to what you're trying to solve for, and then you go from moles back to grams of that new substance. Hopefully this was helpful and will be just one more tool that you can look at to figure out how to do stoichiometry. I'm going to do this in class as well. This is just an extra little introduction to help you out. So I hope that that was helpful, and I will talk to you guys later.